Did you know that copper has been used by humans for over 10,000 years? This remarkable metal has played a pivotal role in the development of human civilization, shaping the way we live, work, and create. From the earliest days of human history, copper has been a constant companion, aiding in the advancement of technology and culture. That's longer than the pyramids of Egypt. The ancient Egyptians were among the first to recognize the value of copper, using it to create tools, ornaments, and even plumbing systems. Their mastery of copper smelting and casting techniques laid the foundation for future civilizations to build upon. Copper's journey from deep inside the earth to the devices we use every day is an incredible story of human ingenuity. Mining operations have evolved dramatically over the millennia, from simple hand tools to sophisticated machinery capable of extracting vast quantities of ore. This evolution reflects our growing understanding of geology and our relentless pursuit of efficiency. It's a story of fire, water, and powerful forces shaping a raw material into a cornerstone of modern society. The smelting process, which involves heating copper ore to high temperatures to extract the metal, has been refined over thousands of years. Today, advanced techniques and technologies ensure that we can produce high-purity copper for a wide range of applications. From the dawn of civilization, humans have recognized the unique properties of this versatile metal. Copper's excellent conductivity, resistance to corrosion, and malleability made it an ideal material for a variety of uses. Ancient societies used copper to create everything from simple tools to complex artworks, demonstrating its versatility and value. Our ancestors fashioned tools, weapons, and jewelry from copper, harnessing its strength and malleability. These early innovations laid the groundwork for future technological advancements, as the knowledge and skills developed by ancient craftsmen were passed down through generations. Even today, copper's importance remains undeniable, playing a crucial role in industries ranging from construction to electronics. Copper wiring is essential for electrical systems, while its thermal conductivity makes it invaluable in heat exchangers and other applications. The metal's antimicrobial properties are also being harnessed in healthcare settings to reduce the spread of infections. Join me as we explore the fascinating journey of copper from ore to market and uncover the science and technology behind its transformation. We'll delve into the history, the processes, and the innovations that have made copper an indispensable part of our world. Whether it's in the ancient artifacts that tell the story of our past or the cutting-edge technologies that shape our future, copper continues to be a metal as old as civilization itself. Copper's journey begins deep underground, in vast and intricate mining operations that stretch for miles beneath the Earth's surface. Here, miners work tirelessly, navigating through a labyrinth of tunnels and shafts to extract this precious metal, where it lies hidden within the Earth's crust. These copper ores are embedded in rock formations, often found in geological layers that have formed over millions of years. The copper is usually mixed with other minerals, making the extraction process quite complex. These copper deposits, formed over millions of years, are scattered across the globe, from the vast deserts of Chile to the mountainous regions of Peru and even the remote areas of Australia. Copper mining is a global endeavor. Each location presents its own unique challenges and opportunities for mining operations. To access this valuable resource, we use various mining techniques. These methods include drilling, blasting, and even using advanced machinery to break through the tough rock layers. Each technique is carefully chosen based on the specific characteristics of the copper deposit and the surrounding environment. The most common method, open pit mining, involves excavating large open holes in the ground to reach the copper ore. This technique is particularly effective for deposits that are close to the surface. Massive trucks and heavy machinery are used to remove the overburden and transport the ore to the surface. This ore, a mixture of copper-bearing minerals and rock, is then transported to processing plants for the next stage of its transformation. At these facilities, the ore undergoes a series of crushing, grinding, and chemical treatments to separate the copper from the surrounding material, ultimately producing pure copper ready for industrial use. Extracting copper from ore requires ingenuity. One method, known as pyrometallurgy, harnesses the power of heat. Imagine fiery furnaces reaching temperatures exceeding 1000 degrees Celsius. In this intense heat, the copper ore undergoes a series of chemical reactions. The copper separates from the surrounding rock, eventually transforming into a molten state. This molten copper, still impure, is then cast into large slabs for further refining. But fire isn't the only way to extract copper. In a process called hydrometallurgy, water plays a crucial role. Think of it as a giant chemistry experiment. The copper ore is dissolved in a special solution, leaching out the copper ions. This solution, now rich in copper, is then separated from the remaining rock. Finally, the copper is recovered from the solution, leaving behind impurities. Section 5. From rock to riches, smelting copper. The molten copper from pyrometallurgy, or the copper recovered through hydrometallurgy, still contains impurities. To achieve the high purity needed for various applications, we turn to smelting. Smelting involves heating the impure copper in a furnace. As the temperature rises, impurities rise to the surface as slag, which is skimmed off. The remaining molten copper, now significantly purer, is then cast into different shapes for further processing. Section 6, a spark of purity electrolysis. For copper to reach its highest purity, we employ a technique called electrolysis. This method is crucial in the copper industry, ensuring that the metal we use in our daily lives is of the highest quality. But what exactly is electrolysis and how does it work? Imagine a process so precise it can separate individual atoms. Electrolysis is a fascinating method where an electric current is used to drive a non-spontaneous chemical reaction. In the case of copper, this means purifying the metal to its finest form. In electrolysis, a direct electric current is passed through a solution containing copper ions. This solution, known as an electrolyte, allows ions to move freely, facilitating the purification process. The electric current acts as a driving force, pushing the copper ions towards the cathode. This causes the copper ions to migrate and deposit onto a cathode, forming a layer of extremely pure copper. The cathode, typically made of a thin sheet of pure copper, attracts the positively charged copper ions, resulting in a gradual buildup of high-purity copper. This high-purity copper is essential for various applications, including electronics and electrical wiring. The purity of copper directly impacts its conductivity and durability, making electrolysis a vital process in modern manufacturing. From the wires in our homes to the intricate circuits in our devices, electrolysis ensures that the copper we rely on is of the utmost quality. Section 7. Copper's footprint, environmental impacts. While copper production is essential for our modern world, it's crucial to acknowledge its environmental impacts. Mining and processing copper can generate waste, impact air and water quality, and affect surrounding ecosystems. However, by embracing sustainable practices, we can minimize these impacts. Recycling copper, reducing water usage, and implementing responsible mining techniques are crucial steps towards a more sustainable copper industry. Section 8. Copper around us, everyday uses. Look around you. Chances are you're surrounded by objects that rely on copper. From the wiring in your walls to the pipes that carry water, copper's versatility is remarkable. Copper's high conductivity makes it ideal for electrical wiring and components. Its resistance to corrosion makes it perfect for plumbing and roofing, and its antimicrobial properties are being explored for medical applications. Section 9. Copper for the future. As we transition towards a more sustainable future, copper will continue to play a crucial role. It's a key component in renewable energy technologies such as solar panels and wind turbines, enabling us to harness cleaner sources of energy. Furthermore, copper's recyclability ensures a continuous supply of this valuable resource. By embracing innovation and responsible practices, we can ensure that copper continues to benefit humanity for generations to come.